Hi, I'm Deborah Miles, your pre-calculus instructor. I'm recording this in January of 2024, and so that's the syllabus I'll be showing you. If this is not 2024 that you're watching the video, then make sure you refer to the syllabus that I've posted in Momentum for you. I do want to show you a few important things in Momentum, and then we will get into a little bit of math, do a little few problems to well, they're more fun than going over the syllabus. To get to Momentum, just go to your Roan State homepage, roanstate.edu, and you'll see Momentum right there in the header. Go ahead and click that. Hope that it works. Oh, great. There we go. All right, click Momentum in the header. You will have to log in with the same username and password that you use for RadarNet. But once you get into Momentum, you should see all of the classes that you're taking this semester, including Pre-Calculus Math 1730-060. So go ahead and tap that. You're going to our course homepage. On that homepage, I have lots of important information. I have my office hours, and I will always be in this room, well, not this room, but on campus, room 115 at 7:30 every morning. We don't have a lot of time in class to answer questions about homework. So if you have questions about your homework, you need to come just a few minutes early and let me help you with that. Or if you can stay a little bit late on Mondays and Wednesdays, that's fine. But you need to do that instead of counting on me to answer all your questions in class. We just won't have time. I've already sent you an email that mentioned that you don't have to buy a textbook for this course. We're doing all the homework in My Labs, and you already paid for My Labs with your tuition. So you have access to My Labs right now. You need that and a 3-ring binder for this class because you're going to print notes and hole punch them, put them in the notebook. If you just put them in a spiral notebook, they'll fall out. You'll lose them. You won't be able to find them when you need them. So 3-ring binder, but you don't have to buy a textbook. I also have instructions for how to join us on Remind. I do use Remind to send class announcements because some folks check their phone more often than they check their email. Sometimes my announcements will just be read your email, or I've just sent an important email. I'm just trying to get your attention to get you to go look at RadarNet and see whatever I've told you that's important. Another app that's important is Radar Alert, not actually an app, but a messaging system. If there are any kinds of emergency or campus closing due to bad weather, if you will sign up for Radar Alerts by clicking that link, then you will get text anytime there is such an emergency or a campus closing. It's a severe weather warning. Also, sometimes I find out about tornado watches and warnings on Radar Alert before that I get them from any other source. So it's a good thing to sign up for, especially spring semester. Then I have a link to all my pre-calculus YouTube podcast. Watching the lecture on YouTube is not the same as being there. One doesn't take the place of the other. But if you have to be out, you can click on the YouTube podcast link and watch the video that you missed. So there's never any reason that you shouldn't have your homework done when you come back to class the next day, even if you were absent. You can still check the calendar, see what we covered, and then watch the video, try the homework. My Lab links. The first time you go into My Labs, you should run that browser check. It's just to make sure that whatever device you're using is compatible with My Labs and you don't have a lot of trouble accessing My Labs this semester. Once you've run that browser check, you can either click the e-text link to see something in the book. You can click math assignments to see what your homework is each day, or you can click grade book, which should always be up to date with your most current average. And I encourage you to keep a check on that. I have 2 links for technical support. The Rome State MyLab technical help is fantastic, and Pearson help for students. A lot of times you have to jump through some hoops to get them there, but I am an expert on my content on math, not on computer issues. So if you're having computer issues, you can email me and let me know, but I probably won't be able to help you with it. You'll have to use one of those 2 links, either the Rome State MyLab technical help link or the Pearson Help for Students link, and let them help you with whatever's going on. If the system's ever down completely for everybody, I will send out probably a remind text and let you know. If you haven't gotten that text, it's a good chance that it's just you and your computer, not the system. So you're responsible for getting whatever computer issues you have taken care of. We do have a learning center in room 159, and our pre-calculus tutor is one that had me both for pre-calculus and calculus. So I call her my mini-me. She basically does things the way I do them. She uses the same words that I use. So I think that she will be good support for you. Actually, or really, if you can get in touch with me, I prefer to help you. And if you email me, I am very good at responding to emails, usually within 30 minutes, always within a day. If I'm awake and you email me, I will answer. If I'm asleep, you don't have to apologize for emailing me at midnight. It doesn't wake me up, but I will answer your email as soon as I am able to, probably right after class. All right, that's all I wanted to show you on the home page. One other thing, under content, there's your notes for the entire semester. And I have it divided into, on the left-hand side, a folder for course information, then each of the test notes, a final exam review. I did this so that in the test 1 notes, instead of having to remember to print your notes every day, I think the test 1 notes are maybe 45 pages. You just print those 45 pages, bring them to class, and you will have everything that you need until test 2. I have already printed the syllabus, the calendar, and instructions for CAM Scanner. I will give those to you as soon as the world thaws out and we're able to meet in person again. I do want to go over a few things about the syllabus. I've also printed today's notes for you. The first section of notes is P.2. And like I said, I've printed those for you, but anything else, the notes after P.2, you will need to print and bring to class. So test 1 notes, there's the PDF. To print from Momentum, you actually have to click, see if I can get that to scroll up far enough. You have to click download. If you click print right here, it just gives you a print preview. But if you click download, you don't even have to save it. Just download it and print from there. You'll get the document just like I typed it in the same format. Let's go back to the syllabus for a minute and then we'll come back to these notes. I don't want to read the syllabus to you. I know you're capable of reading yourself. I do want to point out a few very important things. And if you had me for college algebra, I want to let you know that a few things are different than they were in college algebra. I have my office hours, the times I'll be in our classroom early, and I do have a good chunk of office hours on Monday, Wednesday after class. Please email me from Rome State RadarNet email, not from Momentum. There's a reason for that I don't want to go into. Make sure you sign up for Remind. All right, what most people want to know the first day of class is how their grade is going to be determined this semester. We will have homework every day, and most of the time it will be in my labs. There are a few sections such as graphing that I'll ask you to turn in on paper, but every homework is due at the beginning of class, the next period, so you can work on it up until 8 o'clock the following class day. Actually, you can work on the homework late. You can work on it up until the test covering that material. So if our first test happens to be February 3rd, then you can work on all the homework in that section up till February 3rd, but you get a 5% late penalty for every day that it's late. So try to stay on track. It's important to get the homework done each day after class so that you're prepared to ask questions and to go on to new material the following day. There will also be 4 tests. That makes 5 test grades in all, the homework and 4 tests. I don't give makeup tests, but if you miss a test or just blow a test, then you can take the final to replace 1 test. You can't let that happen twice, but a missed test can be replaced by the final exam score at the end of the semester. Let's see, what else? I'm going to let you just read the rest of the syllabus. I want to get started on some good math stuff. Let's see. Y'all be patient with me. This is the first time I've shared the screen from my iPad to my laptop. Here's what I'm looking for. All right, I want to start some actual content today. We have so much to cover that we need to go ahead and start. And one thing that I want you to understand about me and the way I teach, it's very important to me that you understand the whys behind everything. There's a limit to how much random crap you can memorize. If you don't understand the whys behind the rules, then on test day, you're just going to be sitting there flipping a coin in your head to decide when to add the exponents, when to multiply the exponents, for example. So I'm always going to try to explain why things are as they are. And if you have any questions, please ask me. I'm happy to help you. I can explain things in several different ways if it doesn't make sense the first time. Section P.2 is exponents. And you know, the definition of exponential notation is simply that a to the mth power means multiply a by itself m times. And a is called the base, and the m is called the exponent. The exponent tells you how many times you multiply the base by itself. Now, that's very simple, but I have folks miss exponent problems because of this, not paying attention to the base. Without parentheses, the base is what's only immediately in front of the exponent and doesn't include the sign or the before the number or variable. For example, these first 2 examples, 99 out of 100 dentists surveyed will get example 1 correct. That negative is in parentheses with the 5, and that means the base is -5. So you're multiplying -5 by itself 2 times. And of course, a negative times a negative is a positive. So like I said, pretty much everybody gets that one. But a lot of folks miss the second example. That negative is not inside parentheses with the 5, so it's not part of the base. And one thing that you can use that'll help your eyes see what they need to be seeing. For example, if you have a negative x squared, you know that the coefficient of that x squared is -1. That's basically the same thing as the second example. Since the negative's not part of the base, you may want to write that as -1 times 5 squared. And then you'll understand why that's -25 instead of +25. So whenever there's a common mistake, I'm going to caution you of it, and you just have to work on remembering to pay attention to that caution. Everything in math is what it is because someone noticed a pattern that's almost always true. If there are any exceptions, the exception has to be stated as part of the definition or the rule. So the definition of the 0 exponent is that anything to the 0 is 1. And there's an exception to that. The base can't be 0. 0 to the 0 is something we'll talk about in calculus 2. It's indeterminate form, but all you need to know for pre-cal is anything other than 0 raised to the 0 gives you 1. And that's not intuitive. It's not what I would have guessed if I'd never had a math class. I would have thought anything to the 0 was 0. Seems like it ought to be. But look at this pattern. If we start with the true statement, 3 to the 4th equals 81, that's an equation. One expression equals another equation. And we know that one of the legal things to do to both sides of an equation is divide both sides by the same number. So let's divide both sides by 3. 3 to the 4th divided by 3 would be 3 cubed. And 81 divided by 3 would be 27. 3 cubed equals 27 is an equivalent equation, and it's still a true statement. If we do that again, 3 cubed divided by 3 would be 3 squared, and 27 divided by 3 would be 9. So we have another equivalent equation. If we do that again, 3 squared divided by 3 is down to 3 to the 1st. 9 divided by 3 is 3. And I could have written out here to the side, that's the definition of the exponent 1. Anything to the 1st is itself. So 3 to the 1st is still just 3. Now, notice what's happening on the left-hand side every time I've divided by 3. My exponent started out as 4, and when I divided by 3, it became 3, and then 2, and then 1, and then if I divide by 3 again, that exponent is going to be 0. 3 to the 0 on the left-hand side. On the right-hand side, divide by 3. 3 divided by 3 is 1. And that's a result of the definition of the 0 exponent. We never get, when we start this pattern, we never get 0 on the right-hand side. We always have something divided by itself is 1. So on the left-hand side, anything to the 0, and on the right-hand side, 1. 3 to the 0 is 1, as long as the base is not 0. Now, if we take that one step further, on the left-hand side, reducing by 1 each time, the exponent becomes 3 to the negative 1. The exponent becomes negative 1. And on the right-hand side, if we divide by 3, 1 divided by 3, if we just leave it a fraction, is 1/3. So 3 to the negative 1 is the same thing as 1/3. And I think I know what's going on here. I think I'm recognizing a pattern, but let's do this one more time and see if my pattern is working. If I divide the left-hand side by 3 again, I'd be down to 3 to the negative 2. And the right-hand side, 1/3 divided by 3, we know that's 1/9. But there's another way I could write that. There's another thing that's the same as 1/9, and that is 1/3 squared. So the pattern I think I'm noticing is actually the definition of the negative exponent. Definition of the negative exponent says anything to a negative exponent. From now on, whenever I see a negative exponent, I'm going to think the word reciprocal. Anything to a negative exponent, if I take the reciprocal of the base, the reciprocal of a is 1 over a, that makes the exponent positive. So a to the negative n is 1 over a to the positive n, and we have that same exception. The base can't be 0. That's certainly what happened in these last 2 steps of the pattern we were looking at. 3 to the negative 1 can be written as 1 over 3 to the positive 1. And 3 to the negative 2 can be written as 1 over 3 to the positive 2. Now that can also just be written as 1 over 3 squared, which is how I usually write it. when I take the reciprocal of the base, because 1 to any power is still 1. That's not going to affect the numerator. It's just 1 over the base to a positive exponent. All right, that's my word. Whenever I say negative exponent, this is what I say to myself. Didn't mean to mark that out. Whenever I see a negative exponent, I know taking the reciprocal of the base makes the exponent positive. Now, these 10 examples below really get at the heart of, are you paying attention to what's the base? And do you understand negative exponents? So let's start with number 1. 5 to the 0, that is the definition of the 0 exponent. Anything to the 0 is just 1. In that expression, the base is 5. So anything to the 0 is 1. And number 2, the base, because of the parentheses, the base is 5x. So it's still just something to the 0, and something to the 0 is 1. But that's different than number 3. Number 3 doesn't have parentheses, so the 5 is not part of the base of that 0 exponent. The base of that 0 exponent is just x. And if I need a way to make it very clear to my eyeballs that that 5 is not part of the base, I can write that as 5 times x to the 0. Now, probably on a problem this simple, you don't need to rewrite it with the dot in the middle. But I'm telling you, in calculus, when we get to something called the product rule, sometimes writing that dot will help you separate those two factors in your head. That's 5 times x to the 0. X to the 0 is just 1. And 5 times 1 is 5. So number 2, with the parentheses, with the 5 being part of the base, you just get 1. But number 3, the 5 not being part of the base, you get 5 instead. Number 4, I see that negative exponent, and I think, take the reciprocal of the base, and that'll make the exponent positive. So the base is 5. The reciprocal of the base is 1/5, and that makes the exponent positive. And like I said a minute ago, I will usually just write that, I'm going to say or, because either one's perfectly fine. I will write that as just 1 over 5 squared, because I know 1 squared is still 1. That simplifies to 1 over 25. All right, number 5, the base of the exponent -2 is just x, because there's no parentheses. The -2 is only the exponent of the x. The same dot that helped you in number 3 may help you here also. We'll make it very clear to your eyeballs that that 5 is not part of the base. If 5 is not part of the base, then the only thing that has a negative exponent is that x, and the only thing you're going to take the reciprocal of is that x. So that's 5 times 1 over x squared. If you think of that 5 as being over 1, when you multiply straight across, you get 5 over x squared for that expression. And of course, number 6 is different, because the base is not just the x. Because of the parentheses, the base is 5x. And so the whole 5x has a negative exponent. You're going to have to take the reciprocal of the whole 5x. And that makes the exponent positive. Now, I've deliberately made a mistake here because it's a common mistake, one I want you to watch out for. In number 6, the original base included the 5, But in the way that I've rewritten the problem, the base is just x. Without parentheses, I've lost track of the fact that the 5 is supposed to be part of the base. If the 5 is part of the base here, I have to use parentheses to show that 5 is still part of the base there. And then in the denominator, I can say 5x times 5x is 25x squared. And so you see, we get a very different answer to number 6 than we did to number 5 because of paying attention to what's the base. All right, number 7. The base, because of the parentheses, the base is -5. So -5 has a negative exponent. That means I'm going to take the reciprocal of -5. Is the reciprocal of -5 +5? That's not reciprocal, that's opposite. The reciprocal of -5 is 1 over -5. And again, if I don't have the negative inside the parentheses, I've lost the track of the fact that it's part of the base. If negative is part of the base here, then the negative still has to be part of the base there. And taking the reciprocal of the base makes the exponent positive. Doesn't make the base positive, it makes the exponent positive. So because of the parentheses, we know that that's the same as number 4 was. Wait, not number 4. Where was the negative part of the base? Oh, I guess that's the first time the negative was part of the base. So -5 times -5 is +25. That answer is 1 over 25. Number 8, the negative is not part of the base. You may want to rewrite it just as we did up here. If the negative is not part of the base, we write it as a coefficient, -1 times 5 squared. So number 8, it may be helpful to write that as -1 times 5 to the -2. And we already know what 5 to the -2 is. That was number 4. Number 4, 5 to the -2 is 1 over 25. So this is -1 times 1 over 25, or -1/25. All right, 2 more. Number 9, the base of that -2 is just x. The -5 or the 5 has its own exponent. The exponent of that 5 is just 1. It's not written, but it's understood. So again, the dot may help me. I need to write that as -5 times x to the -2, so that I can see the only thing that has a negative exponent is the x. So the only thing I take the reciprocal of is the x. That's just -5 times 1 over x squared. If I put that -5 over 1 and multiply straight across, that's -5 over x squared. And I think I've just discovered a new pattern, or a new something that's always true. If I have, then I'm going to name it after myself. I'm going to call it the Miles rule of exponents. Here's what I think the Miles rule of exponents is that I just figured out all by myself. I figured out that any factor, let me say it that way, any factor with a negative exponent is going to end up in the denominator. Any factor with a positive exponent, remember the -5 had an exponent of +1, any factor with a positive exponent ends up in the numerator. And if that's true, then I can do number 10 really quickly. I can just say any factor with a positive exponent goes in the numerator, any factor with a negative exponent goes in the denominator. I'm going to put in a middle step. I'm going to work it out the long way and then determine if Miles' rule for exponents actually work. Number 10, I'm going to write that as negative 12 times, since the x has a negative exponent, I'm going to take the reciprocal of x cubed. That will make, or the reciprocal of x with a positive exponent. Y to the 5th as a positive exponent, so I don't need to take the reciprocal. Z to the negative 1, that has a negative exponent, so I'm going to take the reciprocal of z, and now that's to the positive 1. And of course, I don't have to write that 1. Now, if I put my whole numbers or variables over 1, I can multiply straight across. In my numerator, I'll have negative 12y to the 5th. And in the denominator, I'll have x cubed z. So there are a couple things I want to say about this one. But first, did the Miles rule of exponents apply? Did anything with a positive exponent, I keep saying anything, I should be saying any factor. Did any factor with a positive exponent end up in the numerator? Well, that 12 had a positive exponent, and the y had a positive exponent, and yes, the negative 12 y to the 5th ended up in the numerator. Originally, the x had a negative exponent, and the z had a negative exponent. Did they both end up in the denominator? Yes, they did. So I'm feeling pretty good about Miles' rule for exponents. But I can show you why that's not true. The Miles rule for exponents that I was so proud of coming up with on my own, I was thinking I could say any factor with a positive exponent goes in the numerator, any factor with a negative exponent goes in the denominator. That's not true when the negative exponent starts out in the denominator. If I had 1 over y to the negative 3 and I took the reciprocal, then that y cubed would be in the numerator. So there goes Miles' rules for exponents. If I start out with a negative exponent in the denominator, when I take the reciprocal of that factor, it will go in the numerator. The second thing I want to say about number 10, one thing that confuses a lot of people, frustrates a lot of people, if you think the rules are changing on every problem, then math is going to be really, really frustrating to you. The rules never change. If you think they are, then you don't understand the rule correctly. What I'm talking about is, let's say I'm training you all to be tutors, and some very frustrated college algebra kid comes in one day and says, "This is why I hate math. The rules are always changing. You said the factors with negative exponents go in the denominator. Why didn't the 12 go in the denominator? It's negative." Well, number one, you can't use pronouns in a math class. When you say it, I don't know what you're referring to. But what that student said wrong was this. I didn't say negative numbers or negative coefficients go in the denominator. I said factors with negative exponents go in the denominator. The x and the z had negative exponents. That 12 didn't have a negative exponent. That 12 had a positive exponent, and that's why it ended up in the numerator. So here's a big caution for you. The sign of a number, like the 12, has nothing to do with the sign of its exponent. You never take the reciprocal of a number just because it's negative, like the negative 12. You only take the reciprocal if it has a negative exponent, and the 12 did not have a negative exponent. All right, I want to go over the basic properties of exponents with you and make sure that you understand why they are what they are. This first example, 7 cubed times 7 squared. If you're just guessing, you could come up with 4 different answers. Let's say I was going to make this a multiple choice problem. Oops. If I were making this a multiple choice problem, I'd probably say, well, it could be 7 to the 6th. It'd be 7 to the 6th if I multiplied those exponents. Or it could be 7 to the 5th if I add those exponents. Or it could be 49 to the 6th. And I kind of see how somebody would get 49 to the 6th. Or it could be 49 to the 5th. If I gave this problem to 100 different Algebra 1 students, I'd probably get some students picking each one of those 4 answers, and some students would just be guessing. You got a 25% chance to get that right if you guess. If you think about what 7 cubed times 7 squares means, you got a 100% chance of getting that right. 7 cubed means 7 times 7 times 7, and 7 squared means 2 more 7s multiplied together. If you write that in expanded form, you can see that you have 5 7s multiplied together, and that can be written as 7 to the 5th. So the right answer, if this were a multiple choice problem, would be B. That's 7 to the 5th, which is the same thing I would have gotten if I had just if I had just added those original exponents. So the product rule is just a shortcut somebody noticed always happens when you're multiplying 2 expressions with the same base. You multiply 2 expressions with the same base, you add their exponents. Now, the 2 other wrong answers, C and D, both come from multiplying the bases, multiplying the 2 7s. Well, when we wrote that out, you can see we didn't end up with 5 49s. We ended up with 5 7s. So the answer is 7 to the 5th, not 49 to the 5th. Another very important caution. Don't multiply the bases. All right, the next big property of exponents is the quotient rule. In math, quotient means you're dividing 2 expressions, and when you're talking about properties of exponents, you're talking about dividing 2 expressions that have the same base. So again, I'm going to think about what this example means. 3 to the 6th divided by 3 squared. That means 3 multiplied by itself 6 times, divided by 3 multiplied by itself 2 times. And I know that a legal way to reduce fractions is canceling common factors. I can say this 3 divided by that 3 is 1. This 3 divided by that 3 is 1. So all I have left is 1 times 3 multiplied by itself 4 times. I can write that answer as 3 to the 4th. And 3 to the 4th, I just noticed a shortcut. That's what I would have gotten if I subtracted the bottom exponent from the top exponent. And that's exactly what the quotient rule tells me to do. When I'm dividing 2 expressions with the same base, I subtract the bottom exponent from the top exponent. This has a similar caution to the product rule. Some folks will tell me the answer is 1 to the 4th, but we weren't left with 4 1s. We were left with 4 3s. So don't divide the bases, just subtract the bottom exponent from the top exponent. All right, last we have the power rules, and there are 3 power rules. Let's say you have x squared cubed. Well, That's the one folks are sitting around on test day going, is that where you multiply? Is that where you add? If you think about what it means, you'll know. X squared cubed, anything cubed means that times itself 3 times. So x squared cubed means x squared times itself 3 times. You could even break that down further into that x squared is x times x, the next x squared is x times x, and the last x squared is x times x. If you write that in exponential form, we have 6 x's multiplied together. X multiplied by itself 6 times is x to the 6th. And that's what we would have gotten if we had originally just multiplied those two exponents. So that's what the first power rule says. When you have one power raised to another power, you multiply the exponents. All right, the second power rule is when you have a product to a power. A times B is a product and raised to the nth power. Well, think about 5x cubed squared. Squaring something means multiplying it by itself. So 5x cubed multiplied by itself. We could write that out as we did the previous example. We could write it as 5 times x times x times x times 5 times x times x times x. I kind of don't want to do that. I see that I would have 5 multiplied by itself 2 times and x cubed multiplied by itself 2 times. That's just 25x to the, this is the first power rule, one power raised to another power, you multiply the exponents. So that's 25x to the 6th. Our second power rule says if you have a product, this 5x cubed is a product raised to a power, you just raise each factor to the power. We just squared each factor inside the parentheses. So a times b in parentheses to the nth power, you just raise a to the nth power and b to the nth power. All right, last one. The fraction a over b raised to the nth power. For example, 2/3 to the 4th. A lot of students will punch that on the calculator and give me a long not repeating, but non-terminating decimal. They'll just chop it off somewhere and call that the answer. That's an approximation. Unless I tell you that I want an answer rounded to some certain decimal place, I want the exact answer. And the exact answer for this is not a decimal. This is an irrational number, a number that goes on forever without forming a repeating pattern. So actually, it's not an irrational number. I'm sorry, I misspoke there. It does not terminate, but it does form a repeating pattern. 2/3 is 0.6666 that goes on forever. That repetition of the same digit means that it is a rational number. I misspoke there. But I don't want that decimal as the answer. I want you to say 2/3 to the 4th means 2/3 multiplied by itself 4 times. And then you notice that that numerator is just 2 times itself 4 times. And the denominator is 3 times itself 4 times. And then you can evaluate both of those expressions and you get 16/81. That's the answer I want. That is an exact answer. 0.1 something, 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 something. That is not the exact answer. I want you to use the third power rule and say a fraction to a power. You can just raise the numerator to the power and the denominator to the power. All right, that's all of your exponent rules. Now, we almost always will run out of time before we can do everything, every example that I've typed. I just want to give you all the examples I could possibly give you. But these checkpoint problems, these 4, are worked out in your assignment tonight. In the assignment 1 homework, number 13 has a video with those 4 examples worked out. So if you need more, and you probably will, click on that video number 13, watch it, take notes on A through D, just like you've been taking notes on the other problems we've done. Now, just real quickly, I want to do 2 more problems that are maybe a little bit harder than those 4, the 2 that you have, or those 4 that you have videos on. I want to work these last 2 examples. Number 1, I have a quotient. I have an expression in the numerator divided by an expression in the denominator. That video for checkpoint 1 will give you a list of steps for simplifying exponential expressions, and it will tell you that the first thing you do is clear out parentheses. So in the numerator, I have a product to a power. I'm going to raise each factor to the power by multiplying the exponents. I'm using 2 of my rules there. I'm saying x cubed to the -2 would be x to the -6, and y to the -7 to the -2 would be y to the 14th. Again, just multiplying the exponents. In the denominator, x to the -3 to the -3. When I multiply those exponents, I'd get x to the 9th. And in the denominator, y to the 8th to the -3 would be y to the -24. So I've cleared out the parentheses. Now, what you do next just depends on the way you learned it and the way you think. There are 2 different things you could do. I'll show you which one I prefer. You could say, since that x is to the -6 power, I'm going to bring it down to the denominator. Since that y is to the -24th, I'm going to bring it up to the numerator. You can do that, but I prefer to use my product rule and my quotient rule first, and then if I happen to end up with any negative exponents in the answer, I will take care of them as my final step. I'm just going to use the quotient rule and say x to the -6 divided by x to the 9 is x to the -6 minus 9. And with the y's, I'm going to say y to the 14th divided by y to the -24th is y to the 14th minus -24. Now here's another place that folks make a mistake. Instead of saying 14 minus -24, they just look at the original problem and say 14 minus 24. Don't do that. Watch out for it. When I clean up those numeric expressions, I have x to the -15 times y to the 38th. And here's the point where I say I'm not going to leave negative exponents in my answer. So I'm going to write that as y to the 38th divided by x to the 15th. All right, last one. Number 2. The parentheses around that first expression really don't matter because the exponent outside those parentheses is 1. Anything to the first is just itself. So I can write that first factor without the parentheses, 5x to the -4, y to the -2, z. But that second expression, this 5x to the -3, to the negative 1, I have to write the 5, raise 5 to the negative 1, and x to the negative 3 to the negative 1. Going to multiply those exponents, I get an x to the positive 3. 5 to the negative 1, x to the positive 3. Now, I can rewrite it with all the factors with positive exponents in the numerator, all the factors with negative exponents in the denominator. I can do that, but I prefer to use the product rule first. I'd say I can multiply those two 5s by adding their exponents. Now that first 5 has an exponent of 1. So if I add the exponents on the 1, I get 5 to the 0. 1 plus negative 1 is 0. I'll clean that up in a minute. When I multiply my x's, I add their exponents. Negative 4 plus 3 is negative 1. I don't have anything else to multiply with that y to the negative 2, so I'm just going to bring it over. And don't have anything to multiply by that z. I'm going to check that I've added all the exponents correctly. 5 to the 0 is right. X to the negative 1 is right. Y to the negative 2z. All right, last step. I know that 5 to the 0 is just 1. The coefficient's 1. I don't have to write a coefficient of 1. So what I'm left with, this x, y, z, the z has a positive exponent, so it goes in the numerator. The x and the y have negative exponents, so they go in the denominator. And putting them in the denominator makes their exponents positive, and you don't have to write that 1. You can, but you don't have to. So that's your answer. All right. We've gone way over an hour. Perhaps you know all of this already and you don't even need to watch the whole video. But if you are one of the folks who's just been memorizing things that didn't make sense, it's time to stop that. And that's why I've gone ahead and gone through each example and explained why things are the way they are. I want it to make sense to you so that you're not just memorizing crap. All right, what you need to do before the next class, I've given it to you at the bottom. I didn't read the syllabus to you, but it's very important that you understand the policies of the class, so make sure you read the syllabus. Assignment 0 is just how to enter expressions in MyLab and some questions about the syllabus to make sure you've read it. Assignment 1 is over exponents that we just do. In the homework, you only have 2 attempts on each problem. I don't want you to be making 100 on the homework because you have 50 chances on every problem. You get 2 chances on each problem. And when you finish and submit your homework, you can go to the grade book. The link is on our Momentum homepage. You can go to our grade book and click review. Then you'll have those tools that you're used to in college algebra. Help me solve this and show an example. So whatever problems you miss, go to the grade book and review those problems. Another help tool that you'll have is Ask Instructor. That's the link you'll use to send me a problem that you're stuck on and let me help you with it. There are some videos embedded in the homework. I mentioned these 4 problems in the checkbook. Those videos are in the homework if you need to watch it. If you don't, it's okay. You need to organize your notebook and you need to print all of the test 1 notes. When we finally get to meet in person, I will bring you a copy of the syllabus, the calendar, and the notes that we just took, but you need to print the rest of the notes for the rest of the semester. All right, I hope to see you in person soon. Have a good day and stay safe, stay off the roads. Bye-bye.